Today we are going to do lesson 4-4, functions, tables, and graphs. Make sure you put your name and the date on your Cornell notes and write the essential question. Today's essential question is, how can you use function tables to generate and graph ordered pairs? We have two learning targets. The first one is, I can create a function table from a given equation. And the second one is, I can graph ordered pairs from a function table. Rube Goldberg, a famous cartoonist, invented machines that perform ordinary tasks in extraordinary ways. Each machine operates according to a rule or a set of steps to produce a particular outcome. In mathematics, a function operates according to a rule to produce exactly one output value for each input value. The input is the value substituted into the function. The output is the value that results from the substitution of a given input into the function. A function can be represented by a rule written in words, such as double the number and then add 9 to the results, or by an equation with the two variables. One variable represents the input and the other represents the output. You can use a table to organize and display the input and output values of a function. So here's what they mean by that. If we look at this equation, and this is an equation because it has an equal sign. Anything that has an equal sign is an equation. We have two variables here. We have y is equal to 2 multiplied by x and then added to 9. So this is the function rule. And what we're saying is we can put a number in for x and then multiply it by 2, add it to 9, because we have to follow order of operations, and we will get an output for y. And the way we would write that is by using either a function table, which is just an xy table, or, as we know, we can turn our tables into ordered pairs. So, for example, if I put 0 in for x, I would write 0 here as the input. I would do 0 multiplied by 2, which is 0, 0 plus 9, which is 9. So I could say when I put in 0 for x, I will get out 9 for y. And that can be written as over nothing up 9. Vocabulary words to fill in. The first one is a function. A function operates according to a rule to produce exactly one output value for each input value. If we look at our example here of an equation, the rule would be 2 multiplied by something plus 9. Then we have the word input. Input is the value substituted into the function, which is the x value. So we put a number in for x, and then we see what we get out for y. So that is why output is the value that results from the substitution of a given input into the function, or the y value. Example 1 says find the output for each input. And so we look here and we have this equation, an equation because it has an equal sign. So y is the same as 4 multiplied by something minus 2. So right here is our rule. We need to take 4 multiplied by whatever x is minus 2, and that will give us y. So I'm going to fill that into the rule right here. So I'm going to write 4x minus 2. Now I'm going to pick values for x to try and put in and see what I get for y. I am going to start with the number 1, and then I'm just going to go 2, 3, 4, and 5. So when I fill this in, instead of having x, I'm going to input the 1 to see what I get out. So I would do 4 multiplied by 1 is 4, minus 2 is 2. So what I'm saying is that when x was 1, y was 2. Then I'm going to put in 2 for x. So I would do 4, and I put in 2, it's the input, multiplied by 2, minus 2. Remember, according to order of operations, I'd have to multiply first. So 4 multiplied by 2 is 8. 8 minus 2 would be 6. So what I'm saying is that when I put in 2 for x, I get out 6 for y. And you can see, remember that you can make ordered pairs right out of this table. For the next one, I'm going to put in 3 for x and see what I get out for y. So I would do 4 multiplied by 3 is 12, and 12 minus 2 is 10. So this would give me when x was 3, y was 10. Then I'm going to do 4. So 4, put in 4, so multiplied by 4 minus 2. 4 multiplied by 4 is 16. 16 minus 2 is 14. So when I put in 4 for x, I got out 14 for y. And then we have 5. So I'm going to put in 5 for x to see what I get for y. 4 multiplied by 5 is 20, and 20 minus 2 is 18. So when I put in 5 for x, I got out 18 for y. Now one thing I want you to look at here is as the x values go up by 1, the y values are going up by 4. See that? 2 plus 4 is 6, 6 plus 4 is 10, 10 plus 4 is 14, and 14 plus 4 is 18. So I can say that this is increasing by 4. Letter B says to use the rule y is equal to 6 multiplied by x to the second power. Now, one thing I want to talk about here is according to order of operations, you would have to do x to the second power first. And remember, that just means whatever x is multiplied by itself. And then we would multiply by 6. So you always need to do the exponent first. That if we look at PEMDAS, so we have parentheses or grouping symbols, exponents, then multiplying or dividing, followed by adding or subtracting. So we would have to take care of this first, multiplying the number by itself, and then do the multiplying with 6. All right, so over here in my rule, I'm going to write 6 multiplied by x to the second power. All right, so now I need to choose some values for x. I'm going to start with 0 this time. So I have 0, 1, 2, 3, and 4. So I'm going to put in 0 for x, and I'm going to think of this as 0 multiplied by 0. So 0 multiplied by 0 is 0, and 0 multiplied by 6 is still going to be 0. So what happened was when I put in 0 for x, I got out 0 for y. Now I'm going to do 1. So I have to do 6 multiplied by 1 multiplied by itself, which is 1. So 1 multiplied by 1 is 1, and then 1 multiplied by 6 is 6. So when I put in 1 for x, I would get out 6 for y. Now I'm going to put in 2 for x, so I would do 2 to the second power. So 2 multiplied by 2, which is 4, and 4 multiplied by 6, which is 24. So when I put in 2 for x, I got out 24 for y. Now we're going to put 3 in for x, so we would have 3 to the second power, or 3 multiplied by 3, which is 9, and 9 multiplied by 6, which is 54. So when I put in 3 for x, I got out 54 for y. And the last one is 4. So I would do 4 to the second power, or 4 multiplied by 4, which is 16, and 16 multiplied by 6, which is 96. So when I put in 4 for x, I got out 96 for y. All right, so look at this. As x increased by 1, y was increasing by, look at this. I went from 0 to 6 to 24 to 54 to 96. The numbers were getting big really fast, and that's because I had this x squared. Remember, this would show up on our graph as a curve, like a parabola, not a linear line that would just have the x without the x squared. You can also use a graph to represent a function. The corresponding input and output values together form unique ordered pairs. So it says, remember, an ordered pair is a pair of numbers that represents a point on a graph. So here we are in example 2, and this time we're going to be graphing functions using ordered pairs. So they're going to start us off with the equation. I made us a table. So when you see an equation, you first need to make yourself a table, and then from the table, you can go to the coordinate graph. So it says, when writing an ordered pair, write the input value first, or the x, and then the output value, or the y. All right, so we're first going to focus on filling out the function table first. So my rule is 2 multiplied by x. So I'm going to put some numbers here, 0, 1, 2, 3, and 4. So when I do 2 and I put in 0 for x, I will get out 0 for y. So this becomes 0, 0. And I can put that on the graph here in a second. This would be 2 multiplied by 1, which is 2. So when I put in 1 for x, I got out 2. Then we have 2 multiplied by 2, which is 4. So when I put in 2 for x, I got out 4. 2 multiplied by 3 would be 6. So when I put in 3 for x, I got out 6. And 2 multiplied by 4 is 8. So when I put 4 in for x, I got out 8. All right, I set up the graph. You need to pause and set up your graph for yourself. And now I'm going to graph the points that were on my table. So the first one was at 0, 0, which I'm getting from right here. Then I put in 1 for x and got out 2 for y. So I would go over 1, up 2. Then I'm going to keep following these points. So when I put in 2 for x, I got out 4. So over 2, up 4. Then I put 3 in for x and got out 6. So over 3, up 6. And then over 4, and I got 8. So we can see that this graph is increasing at a constant rate. And in fact, if I look here at my y tells me what that slope will be increasing by. It's going up by 2. So it is increasing by 2. All right, now I'm ready for B. So my function is y is equal to x to the second power, or x squared. So when I write this out, I'm just going to write my rule as x multiplied by x, because I know that's what I have to do when I square something. I need to multiply it by itself. Now I'm going to pick numbers. So I'm going to pick 0, 1, 2, 3, and 4. All right, so I would do 0 multiplied by itself of 0 is going to give me 0. So when I put in 0 for x, I got out 0 for y. Then I'm going to put in 1. So 1 multiplied by itself is going to be 1. When I put in 1 for x, I got out 1 for y. Now I'm going to put in 2. So 2 multiplied by itself, 2 multiplied by 2 is 4. When I put in 2 for x, I got out 4 for y. Then I have 3. So 3 multiplied by 3 is going to give me 9. When I put in 3 for x, I got out 9. And then I have 4 multiplied by 4, which is 16. So when I put in 4 for x, I got out 16. Now I'm ready to graph, since I have my ordered pairs of when I put a number in compared to what I get for the number out.